This is an ultrasonic sensor. This can sense objects and display it graphically via a graph, and it can even show you the distance and an angle which it's pointing at. It's a really cool project, and I'm going to show you how it works and how you could use it.
To make the little radar device, you're going to need a few parts. The first part is the ultrasonic sensor. The second part is an Arduino. The third part is a servo motor. The fourth part is a breadboard. You could either have this or just connect it with a bunch of wires, which gets annoying really fast. And, well, you're going to need wires anyway, so you always have those.
This is the ultrasonic sensor. This is what is doing the detecting part of the project.
So the ultrasonic sensor is quite a fair bit complex part in this system, apart from the Arduino itself. So how it works is there are two circles in the front of it. One is an emitter and the other one is a receiver. The emitter sends out like certain amount of pulses in a certain duration of time, and it keeps doing that in like a loop. And when it sends, like say 8 pulses to an object, it starts an internal clock. And when that internal clock starts, the pulse, it just keeps traveling, hits an object, comes back into the receiver. And when the receiver gets the pulse, it immediately stops the clock. Now, the duration that clock was on is the duration of time it took for whatever the pulse is from there and back. And the speed at which the pulse travels is the speed of sound, which here in our code is 0.034 for like smaller distances right here. And so what we do is we take whatever that duration is, we multiply with the speed of sound so we can get our distance. That's your basic math formulas. But that distance right there, it isn't the distance to that object from the sensor. No, it's the distance to that object and back, like from the sensor, right? So you're going to have to divide that by 2 in your code to get the actual distance. Now, this should have been hard-coded in like a function, and we do that in our own code, make it a get distance function. But that is how the basics of this part works. It is a cool part, and yeah, this is probably the most complex part here.
Fun fact, the reason a lot of airplanes, fighter jets, or stealth jets have these sort of weird angles and they look like a preschooler cut them out of paper is because those weird angles and those reflecting sort of plates, they deflect the ultrasonic rays to a different place so that they can't come back to the receiver and actually register them in. That's why you can't spot these kinds of planes on the radar. This is the Arduino. This does a lot of the thinking for the project, and the brains, maybe. This is a servo motor. This does the oscillating and actually moves the sensor around so it can see. And this is the breadboard, which connects all the parts together like a big wire.
Now we get to the code part of this system. And now the code is basically what's controlling everything in the back end. And how it works is pretty simple. At first you define all the variables, so what pins are what is controlling what, and then you get to the setup. And where the setup is, this loop only runs once. This function, actually better than loop, it only runs once at the beginning of it, and then it just doesn't. Here you can initialize your servo. So in the beginning we defined that the servo is just going to move 180 degrees back and forth. Here the servo is like, okay, yeah, I got it. I'm going to move 180 degrees back and forth. You can also initialize that what the emitter is going to do and what the receiver is going to do, because we said that the emitter pin is going to go to output mode, and then the receiver pin is going to go to input mode. So we can just clarify that in the beginning. You don't need to do that again and again in the loop, and it's also going to take a lot of space. Next, you get to the main loop. Now, in here, you run whatever you're going to do infinitely, like until you turn it off eventually. Here, you just have the get distance function that you wrote down below that we defined, that we defined there. It does the same things, takes the speed of sound, multiplies it by the duration, blah, 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 gets the distance. And the graphics of this are actually in another program, which I also got inspiration from another YouTube video, which I will put in the link in the description. It's really much more complex than this, and that's what usually graphics is. But this doesn't have to do with any of the graphic stuff. After that, you just have your get distance function, and that's about it. This is a pretty simple code, pretty neat, pretty self-explanatory.
This is a much more neater version of our project. And you can see here all the wires laid out and everything connected to the right place. This is our breadboard. This acts as a giant wire connecting all of the voltage and our ground cables. And voltage and ground is how a normal circuit works. You need one powering in and the other one just letting it out. And they usually go on this bottom two rows. Our ultrasonic sensor has two data inputs. The other two are just power. One of them is the trig pin, and the trig pin usually just is the emitter pin, you can say. And the echo is just the receiver pin, and those are connected straight to our Arduino, the brains. We specified where it is connected in the code. Same goes with the servo motor, because the servo motor has 3 in total. 2 of them are just power, and 1 of them is just the data we feed it, so like what angles it's going to go, how long it's going to go for. That's about all. The Arduino itself also needs power, which it can get from this one outlet, but it also needs to be plugged in to the breadboard to supply it to every other part. It is a fairly simple mechanism. It's not complicated at all. As you can see here, the sensor is all set up, and so is the graphical display. And it spins back and forth 180 degrees. You can see it going from 0 to 180 right down here. And you can see if any object comes, it can show a little red line here, like there and there, which are probably from the keyboard in that box over there. And it even shows you the distance from the sensor to that red line there. So if I were to take this note card up right here and put it somewhere over here, it can oscillate there and then show it on the display over there. Yeah. And if I were to put it at an angle, like this side facing forward, then it wouldn't really be able to sense it that well. See? Like right there. This is a really cool project, and it is my first. So I hope to improve on this much in the future.